Hello everyone, Dr. Vaughn. It's Sunday morning and we're going to do a quick video for homework 4.2, and if we have time 4.3. If not, I'll make a separate video for that. So here we are in number 1. I only want to look at part C for this question because it kind of incorporates a lot of the things you have to do on the other one. So the most efficient way to kind of do all of these parts is to open this in StatCrunch, and once you have your data loaded over here, the X and the Y, then I'm going to go to just the stat feature. You could, if you just want the scatter plot, you can go to graph. But if I want the scatter plot with the regression line on it, I'll get that through the stat and then regression, simple linear. I'm going to select X for the X variable and Y for the Y variable. Skip everything, but I want to go down here and make sure that I have this fitted line plot selected. So then I'll press compute. Here is the equation of the regression line. So these are the coefficients. This will help you answer, I think, part B. And then, there's a little arrow here, and it also says this is window number 1 of 2. So if I go to the second window, here's the scatter plot with the regression line in red graphed on it. So that'll allow you to answer part C on this question. All right, so I'm going to close down my stat lab. The next question I wanted to look at was this one right here. And we're only going to do one part of this. I don't really know what the other 3 parts are that's remaining. But here they actually give you the equation of the regression line. And just for convenience, I'm going to copy that over into the whiteboard. So let's write this as a y hat, just so I have it handy and I don't have to keep flipping back and forth. 692.0, that's the x. So in StatCrunch, that part comes out second, not first. And then plus, and then the intercept, which comes out first in StatCrunch, is written second in a more traditional model, 696. So that's our regression line, and this is the one we can use to make predictions. So the percentage of 25 years and older, that's our population, and hold at least a bachelor's degree. So they tell me also the correlation coefficient. I don't think I need that for at least part A. So I want to do a prediction. Predict the median income of a region in which 25%, that's all the population, have at least a bachelor's degree. So that percentage is the input. So the 25% is the independent variable, and then the median income is the output. So the X is the percentage, that's 25. So all I'm going to do is plug in 25 for X and then solve for Y. So the predicted Y value is, and I need to do my calculator work here, 692.0 times 25 plus 15696 equals 32,996. And that's what I'll type into the box for part A. So that's using the regression line to make a prediction, 32,996. All right, so like I said, I'm going to skip the other 2 parts of this particular question, and I'm going to go on. I want to look at least a couple more. All right, we're going to skip this part. This is just kind of fill in the blanks. They give you some information. And so we're going to do this one. So here's actually just finding the least squares regression line. They give us the data. So I'll click here to open the car weight and MPG. So we're using the weight as the dependent variable, independent variable, and the gas mileage as the dependent variable. So I'll open it in StatCrunch. We'll again create the regression line, stat, regression, simple linear. X variable is going to be weight. Y variable is going to be miles per gallon. I don't really need any of this other stuff. You can do the fitted line plot if you want. And now we'll compute. So here, right here is our regression equation. Again, there's the weight is the independent variable. And so that's the coefficient. That's what's going to be written first when we go over and look at the Pearson. So notice here's the X. So that's, I'm going to put in minus 0.006, and it wants 5 decimal places. So 0.00634, and then 7 is the 5th one, but that 7's got to round up to be an 8. So it's going to be negative 0.00618. and the intercept to 5 decimal places is 40.21553 when I round it. 40.21553. Oh, it says, I'm sorry, it says round the constant to only 2 decimal places. So I'm going to round this to 40.22. All right, and then it's just some interpretation questions after that, and maybe make a prediction. But that's how you find the regression line in StatCrunch. So I'd like to go up, and next I'm going to look at, I think it's number 6 or 7. Yeah, so 6, we could do this one really, really quickly. I like to close out StatCrunch in between. Just open it up, and this is multiple choice, so we should be able to find the regression line really quickly by just going stat, regression, simple linear, x and y, and then compute. So I get this number right here, negative 0.206 is the coefficient of the x, and so that rules out C and D here, and B is a positive, so it's got to be A by just looking at the coefficient of the x, which again in StatCrunch comes out second instead of first, so be careful of that, but it's the number that's in front of the x. And then we will look at this question 7. This one is a little bit, has this kind of is it reasonable sort of question. So let me exit out of here. We'll load up the data again in StatCrunch, and we'll do the regression line in order to pick the right multiple choice question anyway. Simple linear, x and y, compute. All right, so here's our regression line. Okay, 5.044 times the hours, and plus 56.11. All right, these were all the same, except some of them were negative. This is not negative, it's got a positive here. So it's going to rule out for me B and D. So the only choice now is between A and C. And I'm going to look at the y-intercept. They both have the same y-intercept, 56.11. Right, so that's everything I need from here. It's still between A and C. But in this case, I'm going to select C because this data value that they want us to make a prediction about, 15, is outside of the range. We built the model with X values that are all between 2 and 8 hours of sleep. So someone who slept 15 hours is an outlier. It's way outside of that. We call that extrapolation. So it's kind of unreasonable to expect that the model, which was built upon sleep hours between 2 and 8, would extend out to 15 hours. So I'm going to select choice C here. Okay, and the last one that I'll do, at least for this portion of the video, is we'll at least look at 8. I think I wanted to skip that one. We'll go on to 4.3, but let's take a look. All right, yeah, so this one's pretty similar to the one we did just in number 7, so I was going to skip that one. All right, so now we're going to, I think we have a little bit of time, so we'll go into section 4.3. All right, so now we're going to do the coefficient of determination. This is the R squared value. So in this particular case, the R squared is the square of the correlation coefficient. So in this case, you don't have the actual data, and so you just have to make an estimate about it. The one thing you should always remember is that R squared is positive, so it's going to rule out A as a choice right off the bat. Now you kind of look at what, how strong is this correlation? The R itself is negative, but is it really strong correlation, or is it pretty weak correlation, or is it somewhere in between? And then you can choose between these based upon your estimate of, if you think that the correlation here is pretty good, like negative 0.6, you take negative 0.6 squared, and you're going to get something like 0.36. So, this 0.76, you'd have to have something pretty strong, like a 0.8, 0.9 kind of correlation, and I don't think it's that strong, so I think that the answer here is D. Okay, well I guess I got that wrong. So let's see, assuming the scales on the horizontal and vertical axes are the same, it's probably something like this one then. Yeah, it's just a guess. Alright, so let's look at one where we actually have to compute something. Okay, so use the linear coefficient. You're just going to take the square of that and then change it into a percent. So that's just a calculation. Just square that number and then, you know, shift the decimal point over 2 places. Okay, we don't have to calculate anything here. All right, let's try this one. So we're going to do the least squares regression line. Explains the coefficient of determination is what explains the variation in the output variable, the dependent variable, that can be explained by the input variable. So we're going to just copy this number 80.8 into this box, and it's the variation in the output variable, which is the y, which is the length. All right, now we're actually going to compute this coefficient of determination. So if we open this in StatCrunch, then I'll press Stat and Regression, Simple Linear Regression. I'll put the X in and the Y in, and so we can look at the fitted line plot if we want. We'll hit Compute. So when you look at this, here's the model. You know, the height x equals 0 plus 1y, but when you look at the correlation coefficient, it's 1, so this is perfectly correlated, and the r squared in this case is right here, it's 1 also. So we probably should have known this, but that means it's 100% when you shift the decimal place over 2 places. Now it says round to 1 decimal place is needed, so you can probably put 100.0% in here. All right, I'm going to stop this video at this point, and I'm going to try to diagnose this. Maybe I'll do a second video and figure out what I did wrong, but let me just get back with you in just a minute.